All right, so today we're going to talk about greatest common factors. And we're going to learn a couple different ways to find a greatest common factor. Greatest common factors are important when we are reducing fractions and we are trying to find common denominators. So, we're going to go ahead and get started today. In your groups, you're going to try to solve this problem. It says a number divided by 9. When the quotient is multiplied by 6, the product is 108. What is the number? And explain how you found your answer. You may work with your groups. And you have approximately 3 minutes to solve this. Ready? Go.
18.
I'm sorry. What did we get? 18. Anybody else get this?
No. I did. I don't think that's different. It's 12.
Okay, listen up. Check it out. A number is divided by 9. Number divided by 9. That equals something. Okay? The answer of this, so multiplied by 6 equals 108. This is where you guys got 18, right? Yeah. It's divided by 6 on both sides. N equals, it's 148, that's 18, correct?
Yeah.
Here's the problem though. This is the answer to this problem. The number that we were looking for initially, divided by 9, will give you 18. So now I have to multiply 9 and our number that we were supposed to begin with is 162. So, you guys started the problem right, but you lost track of the fact that the number that you were looking for in the first place was the quotient to figure out the number that you wanted to find in the end. Okay? Word problem. It is not both. This 18, you only needed to solve that so you can find 162. 162 is the answer. 162 is the answer. So those of you that got 18 didn't finish the problem. Sorry, guys. Okay, today we're going to do some factoring. We're going to start by reviewing factor trees. Factor trees are something you did in 4th grade. How do you know when a leg of your factor tree is complete?
When there's no more.
Mr. Cooper.
When it's prime.
When we have a prime number. So, in this case, when we see legs that are straight, that means what needs to be in this box?
The 2, a 4.
What kind of number needs to be in that box?
Prime.
A prime number. Okay? So, somebody tell me 2 factors of 30, and one of them needs to be prime. Richie.
3 times 10.
3 times 10. So 10 is not prime, it goes over here. 3 is, it goes here. My 3 is going to come down to my next box. Now I need 2 factors of 10.
5.
Show Walter.
5 times 2.
5 times 2. Now we're coming over to 36. I need 2 factors of 36. Now look, they're both legs. We have legs here, and we have legs here. So we know that neither one of these numbers are going to be what? Neither one of them are going to be prime. Yes, dear. What? Oh, the factors of 36? Okay, tell me. 12 times 3.
3 is the prime.
But 3 is prime, and this is already set up to where they're not going to be prime. Yes? 6 times 6. So now, prime factorization of 6 is
3 times 6 times 6. 3 times 3 times 3 times. 3 times 2. 3 times
3 times 2. Okay? So we have 3 times 2, which means if that's this, then this is going to be the same. Okay? Now, you boys done? You done, Dewey? Now what we're going to do is we're going to match. We're going to pull out the common numbers that are at the bottom. So, I have a 5 here. Is there a 5 over here?
No.
No, so I don't need the 5. I have a 2 here. Is there a 2 over here?
No. Yes.
Okay, so I'm going to circle the 2. I'm going to circle the 2. I have a 3 here. Do I have a 3 over here?
Yes. Yes.
Circle the 3. Circle the 3. I'm out of numbers over here, aren't I?
Yes.
Okay, so all I need is the 3 and the 2. So I have 3 times 2 equals
6.
6. So my greatest common factor is
6.
6. So, when you're doing factor trees, every time something matches, you pull 1 out. Then you multiply it together. You can end up with multiple digits, more than 2, that match. Okay? You can end up with 4, 5, 6 different numbers. And you have to multiply all 4, 5, or 6 numbers together in order to find the greatest common factor. Okay? In this case, we only had 2, so it made for a very simple problem. All right?
All right.
Moving on. So, in this question it says the school has 108 bookshelves and 72 chalkboards. The school will place an equal number of each item into the classroom. What is the greatest number of classrooms that the school can equip with bookshelves and chalkboards? So we need to know what the greatest common factor of these two numbers are. So we know how many classrooms we can put the same number of bookshelves and the same number of chalkboards into each one of the rooms. Okay? Now, when I initially read this problem, I was like, well, that's easy. They can do 72 classrooms because each classroom can get 1 chalkboard and each classroom can get 1 bookshelf, and they'll just have leftover bookshelves. That's not what they want to do. So we need to figure out how many classrooms we're going to put chalkboards and bookshelves in, okay? So we have 108 and 72. Now, I will tell you, 108, when I look at big numbers like this, if they're even, I always just pull out 2 right away because it gives me a smaller number to work with. And smaller numbers are easier to work with. Okay? So rather than sit here and try to figure out for an entire day, well, I wonder what can go into that. I just automatically 2, and that's going to be 54. That's still even, right? So I just pull another 2 out. 27, it's not even anymore. Who can give me factors of 27? Yes. 9 and 3. I always put my prime number first, so my tree grows to the right. So when I'm done, I can just bring these down. Okay? Factors of 9?
3.
3 and 3. Now I come over here to 72. Same thing, it's even, so I'm just going to go ahead. 36. Oh, we just did this one, huh? So we had 6 and 6, and then we went 2, 3, 2. Alright? If you pay attention when you're doing your prime factors, you're going to find that you're going to run into, like I didn't start with 36, but 36 came right here. And remember, we just did 36. So if you pay attention to the numbers that you've done, you can check your work as you go. So that's the same as what I just did. So now I'm going to match numbers. I have a 2. Do I have a 2 over here?
Yes.
I have a 2. Do I have another 2 over here?
2. Yes.
I have a 3. Do I have a 3 over here?
Yes.
I have another 3. Do I have a 3 over here?
Yes.
I have one more 3. Do I have a 3?
No.
I have a 2, and I'm out of 2s over here, right?
Mm-hmm.
So I have 2, 3, 3, 2. So 2 times 2 times 3 times 3. 2 times 2 is 4. Okay? Times 3 is 12. Times 3 is 36. So my greatest common factor is 36. Okay? And this is kind of cool if you look at it like this. 2, 2, 3, 3, right? 2, 2, 3, 3. If I get rid of all these, I have just a 3 left. 36 times 3. 108, right? Over here, the only thing I have left is a 2, right? So if I multiply 36, well, 36 and 2 right there, 37 and 2. Those are the first factors. Alright? So far so good?
So far so good.
Alright. Here we go. We're going to run off to our examples. Chapter 8, Lesson 2.
Page
Prime factorization.
Page 557.
Page 557. Your homework tonight will be 559 and 560. Alright, so say you'll have to complete whatever classwork you don't finish. Okay. Seaverville Middle School arranges their sports trophies in rows in a display case. There is an equal number of trophies in each row. Each row has only one kind of trophy. What is the greatest possible number of trophies in each row? So we have volleyball, football, and baseball trophies. There are 40 for volleyball, 24 for football, and 32 for baseball. So, at a quick glance, I would say that their football team needs a little bit of work. Their volleyball team does pretty well, and their baseball team's coming up. And then I remember, you probably don't get more than one trophy for football a year. Volleyball goes to tournaments, so they can probably get a lot. Alright, I'm rambling, sorry. So let's take a look. We're going to start with volleyball. Volleyball had 40 trophies. They gave us one of the factors, 4. 4 times what equals 40?
10.
10. They already broke down 4, 2 times 2. 10 factors of what? 5 times 2. I would write it 2 times 5, just because then all my 2's are together. Alright. Doesn't really matter. Then we come over here, we have 24. This is the football trophies.
6.
4 times 6 is 24. Thank you, Richie. Use your hand. 2 times 2 is 4. Remember what I said about factorization? Look, we already did 4 over here. So here's 4 again. Alright. Now we come to our next one, and there's another 4. 2 and 2, right? So 4 times what is 32?
8.
Now,
2 and 4.
single leg,
2.
right? So what's going to go here?
2.
The 2.
4.
4.
2.
So that's 2.
2.
2. Alright, now, we're looking at 3 different numbers. 3 different prime factorizations. Okay? So what we're going to do now is we start with our 2. I have a 2 here. I have a 2 here. And I have a 2 here. I have a 2 here. I have a 2 here. And I have a 2 here. I have another 2. And I have a 2 here. And I have a 2 here. I have a 5. Do I have a 5?
No.
No 5. I have a 3 here, but I'm out over here, right?
Yeah.
So I'm done. These 3 2s are what I'm going to have. So I'm going to have 2 times 2 times 2. Okay? So you can see here. The common prime factors are 2, 2, and 2. That's what we just found. So we have 2 times 2 times 2. Or, what is 2 times 2 times 2?
8.
8. Because 2 times 2 is 4, times 2 is 8. So what is the greatest number of trophies that can be placed in each row? 8. Alright. Now they're going to show us a different way to do this. I would like to see factor trees. With that being said, I think it's important that you at least see what I'm about to show you. What are you going to do tonight for your homework?
Factor trees.
Thank you. You're going to do factor trees tonight for your homework. Okay? Now, example number 2 says find the greatest common factor of 60 and 54. We're going to make an organized list of factors. So instead of a factor tree, we're making a list. Okay? This is the way the list works. We start with 1. 1 times 60 is 60. Then we go to 2. 2 times 30 is 60. 3 times 20 is 60. 4 times 15 is 60. 5 times 12 is 60. And 6 times 10 is 60. Why does it stop at 6 and 10? Why isn't there 7, 8, 9, and all that other stuff? Yes, Richard?
Because 7 can't go into 60 because it's higher.
There is nothing that you can multiply any other numbers by that will give you 60. That's why. These are the only factors of 60. So then we come down here and we do the same thing for 54. So 1 times 54 is 54. 2 times 27 is 54. 3 times 18. 6 times 9. You can see there's no 4, there's no 5, there's no 7, there's no 8. Okay? And that's it. We're done. Then we're going to circle the common factors. Okay? So I have 1, 2, 3. I have a 4 here, but no 4 here for 54. I have a 5, but no 5 for 54. 6, I have a 6. I have a 9, 10, 18, no 18, 27, no 27, 54, no 54. So my common factors are 1, 2, 3, and 6. Can anybody see what number is always going to be a common factor if you do it this way?
6.
What number is always going to be a common factor? 1. 1 is going to be everywhere. Okay? Now, in this case, our greatest common factor of 60 and 54 is
6.
6. That's the greatest number that we circle that they both have in common. Okay? Now, Again, what would I like to see on your homework tonight?
Fractions.
Factor trees. I think it's important that you see this in case one of the problems shows it to you like this, but the prime factorization using factor trees is, I think, by far the better way. Because what would have happened if I would have went through and made this list and left 6 and 10 out? What if they just weren't there? Would I have realized that they weren't there?
Yeah.
I would have?
No.
No. But if I would have prime factored it out, I wouldn't have had to worry about missing something. Is that, you guys understand what I'm saying?
No. I don't.
You don't? When I prime factor 60 out, that's, I'll go with 6 and 10. Okay? I'm done now. It's all prime factors, right? When I make my list here, it's possible that I could go 160, 320. What did I just skip?
2.
Would I notice when my list is finished that I should have had a 2 and a 30 there?
Yeah.
You sure? I'm going to have all these numbers besides 2 and 30. Do you think I would have realized that they should have been there?
No.
Probably not, huh? But by prime factoring it, over here, there's no way to leave anything out. Everything's there. You see why I like this better? Okay? Because this way, I mean, they're both going to get you the right answer, but if by some reason you were to leave some of these out, like 6 and 10 or the 30 and 2, you wouldn't realize it, and then you'd end up with the wrong answer. Okay? So, prime factor. All right, here we go. So, our guided practice for today. We're going to find the greatest common factor of each set of numbers. We're going to start with 8 and 32. Okay? So, they want me to make lists, which I will do because they're asking me to. Okay? I can go through and I can circle them. And my common factors are 1, 2, 4, and 8. And my greatest common factor is 8. Fine. But look, I can do the same thing. 8, 2 and 4, 2, 2. 32. I'm going to go 4 and 8. Just because I just factored out 8, so I know that I'm going to go 2, 4, 2, and 2. Bring my 2 down. And then I'm just going to go 2 and 2. Alright? I have 1, 2, 3 2s here. 1, 2, 3 2s here. 2 times 2 times 2 equals 8. Yes. And okay, Ricky came up and showed us, he started making our lists, and then I pointed out to Ricky that this 3 right here, the largest factor of 3 is 3. So when we're making our list, as soon as we hit 3, we can actually stop. Okay? I mean, granted, we could keep going, and this would be, we just have a 12 there, and then here, 6, 9, and 18. But we're looking for our greatest common factor. So the common factors here, the first one, all of them are going to have it's 1. Our other common factor is 3, and the greatest common factor is 3. Prime factorize 3, it's done. It's prime already. 12, 3, 4, 2, and 2. Okay? 18, 2 and 9, 3 and 3. So I have a 3 here, a 3 here, 3 here, and there's nothing else to go with it, so 3 it is. So you're going to use your factor trees to find the greatest common factor of multiple numbers for your homework, for your independent practice. Yes, sir. All right. So you're going to do the number. Is there 15?
15.
There are 15. So there's 3 and 4, 5 and 6, 8,
9,
10,
11,
11.
It's 11.
Listen. Make sure you read through them. There are charts. Here are your numbers. I will give you a hint. It's all greatest common factor. Okay?
12, 13, 14,
Which one doesn't belong?
8, 20, 20, sure.
Listen. That's part of the thing that you guys do. You didn't even read the question. It wants 8 to be the greatest common factor of the remaining numbers. So you need to figure that out. Which 3 numbers will have 8 as the greatest common factor? Remember what I said? Factor tree all of them. Make sure which ones are going to have.
Okay.
Okay? And the last one.
15.
How can you find the greatest common factor of 2 numbers? You need to give me an explanation. Is there only one way to do this?
No.
No, which means that when you're at home, you're like, well, I think this is right, but I'm not 100% sure. It probably is right. Because there's more than one way to find it. I showed you 2. Describe one. Okay? All right. And if you need help, what will be on your homework? What will be on our video? The answers will be on your video.
Okay.
You have the next 10 minutes to work on your classwork. Go for it. Work quietly. What's going to happen tomorrow if your work's not shown?
Your check. It doesn't count.
If your work isn't done, your homework's incomplete, correct?
Yep.
All right. Which is why if you watch our YouTube video, what will you find? Because even though I give you the answers, you still have to what?
Show your work.
Exactly. All right. Quietly, get to work.